2, 1, something like that. Welcome, everybody. Tonight in Dallas is January 4th, 2022. Happy New Year from Dallas Personal Robotics Group. This is our regular Robot Builders Night virtual, where we normally just go around the table, talk about things largely related to robots, design, construction, software, algorithms, and very often adjacent random things that are fun, or the things that it takes to enable making robots. So before we dive in, I'm going to just mention a little bit about club housekeeping items and related things. So for those that aren't aware, there's a really active chat server on Discord for robots. It was founded by Murray, who came to say hi and left a moment ago. If you're interested in that, send a chat here on this meeting and we'll get you a fresh invite. And there's a lot of interesting things going on that Discord. Some discussion in the next few weeks or month. We normally have our annual meeting where DPRG is a formal 501c3 organization. We normally have the annual housekeeping for that in January, but things are a little delayed this year. So what's going to happen at the moment, the plan is, I have to verify this with the other board people, but we will defer the normal meeting from the second Saturday to the third Saturday. So we'll have, and we'll split it into two parts. So the first part will be Saturday the 15th, not this coming Saturday. And there, hopefully by then we'll have a proposed slate of candidates and we'll have better defined rules changes. So for example, we've had some discussions around different membership level. So once we get those a little better formalized, then what we have to do per our rules is put them up like at least 2 weeks before voting on them. And we need a quorum to vote on them. So we just didn't have enough time to do it this year, which means that in February on some TBD date, we'll have part 2. That's when we'll have the actual election. I'll give a review of 2021 as the outgoing president, since I can only serve for 2 terms, and it's a good chance for someone else to carry on. And then the incoming president, whoever we vote in, twist arms and vote in, they will lead us off on a discussion for the next year, for this year, 2022. And then we also have Jack Jones. I've been working with him every couple of weeks. He's been a member of DPRG since, I don't know, middle school or early high school, and he's now in middle of college years. And he's going to give a presentation on the journey that he's followed into robotics. Is there anything else anyone would like while we still have this slide up that we should put on the screen?
Well, I have a question.
Okay.
Voting is to be done by voting members and DPRG members. And as I understand, that means people who have paid their dues, which I haven't done in years. So who exactly can vote? Has anybody else here paid any dues in the last year or two?
Yeah,
it really is just me. Look, even Chris has paid dues.
There's 30 or 35 who are current.
How humiliating.
Yeah, it happens. Well, I mean, we're not terribly strict about it, right? It's
only $40.
Informal organization, so
it's a great value,
and it helps offset our costs. Which, I mean, at 30 or 35 people, it's right on the edge of keeping us current with the makerspace where we have our physical stuff stored. A lot of it.
Yeah, David, you should join. You might learn something.
Yeah, really, I'm being totally made to feel selfish here.
We're not calling anyone out, but you can call yourself out. That's fair.
Well, what I have always done was I figured that in order to participate in a competition, that you need to be a member, and so I would show up at the competition and pay my dues.
Yeah. Okay, we'll deal with that. Anyone else have anything else at this level? Okay. With that, and for those that don't know, I am the current president. I guess I said that in the slide, didn't I? But So I'll be voted out for sure by board rules soon. But until then, I'll keep serving, and the rules allow that for those that haven't read the rules until we have an election.
Thank you.
Okay, hello, Harold. So
Now, wait a minute. Does that mean we can keep you president just by postponing the election?
I really hope not, but I really hope nobody reads that into the bylaws. I suspect somebody could, but I think it's bad form anyhow.
I move that we postpone the election until this time next year.
Oh, damn it.
I think,
Wait a minute, you can't.
Because
vote if you-
COVID, and you know.
You can't move because you haven't paid up.
That's what it really is about. It hasn't paid up.
Just reasons. Reasons. That's why. Reasons. That's all you need to know is reasons.
Okay, I'm going to derail that. Carl's another year just by postponing with something completely different. This is only marginally related. It's not even related to robotics. It's just more electronics and hacky things. So I'm not going to play them, but these two YouTubes are amusing. This guy has made an organ that runs on Furbies. It's kind of amusing, and then he has this synthesizer wall that has 1,000 oscillators in it. For people that like patch cords, he can patch 1,000 oscillators together. But anyhow, that's the only thing I have to contribute tonight, aside from some boring housekeeping slides and a little facilitation. So with that, I think we had a couple names to get started. And before that, so just to set the stage, I know a number of us have received this Kickstarter in the mail, the Oak D Light depth sensing camera with all kinds of horsepower and cameras and stuff on board. I haven't powered mine up, but I know some people have. There's been discussion, so hopefully we'll have some folk talk about their findings on this tonight. A little unboxing party. But aside from that, we have first online, maybe a quick update from Doug D. And then if Paul, if your monitors and stuff are ready, then we could, okay, good. We can go after Doug D. So Doug D, what you got?
So last week I talked about modifying my RC car here so that I could turn it into an autonomous robot. And it was a complete failure on this particular model because everything's all glued together. You can't get to the stuff without breaking the crap open. So I'm going to have to go to the new in box, not yet open car and see what I can do, but I ran out of time because my day job got in the way, but I'll get to it. More updates to follow. That was quick.
That's cool though, in a way. It'll be good to see you jump on the real deal, you know, not
I
these
know. I was just hoping to practice on the little one before I opened up the real one.
Think of it this way. This will get you to the end game faster.
Yeah.
Cool. Okay. Well, thanks, Doug. So, Paul, what's going on in your court?
Well, so I was hoping to that someone would demo the demo application that came with the light camera. And David, I know that you were running it, but I can't remember what the thing's called and where it's at.
it's depth AI, DEPTHAI.
Put it in the chat.
Well,
Oh, and it's called Depth AI Demo. That's right.
yeah.
Okay. So let's see. Thank you, Doug. Let's see if we can't just share a desktop here. Okay. Do you guys see my desktop?
Yep.
Are you guys seeing my desktop?
Mm-hmm.
Yes.
Yes.
Hello?
Yes.
Paul, the link I have here, or the command I have here, Python 3 depth AI underbar demo.py.
Hello?
Can
Yeah.
you hear us?
Did you guys hear me or
Yes.
Oh, see
Can you
my-
hear us? I don't think
see
you
my
can hear.
desktop? Oh, no, I can't hear you. Let me
Yep.
see why.
Put another quarter in the modem.
Probably that acoustic coupler has come
Hmm.
loose.
Log back in.
Okay, there we go. Can you hear us,
Can you hear
Paul?
me now?
We can
Yes.
still hear you.
Yeah.
Can you hear me now?
Yes.
Yes.
Can you hear us?
Okay, I see nods, but I don't have audio.
Oh, boy.
Oh boy, why not?
Can you do it in hand language?
He doesn't need to hear us. We just need to hear him.
Maybe it's time to get the semaphore flags out. you know.
Probably using Windows. You should switch to Linux.
I'm gonna have to leave and rejoin.
Okay.
There's one thing that I've noticed. Okay, I have the demo running on both my Pi and on Windows. And on the Windows, I expected it to look like the Pi because that's what happened with the OD. I thought it would be the same demo, but it's the one that they tell you to use during setup is actually like a Windows application, and so it's a little bit different. If Paul's used in Linux, I'm real interested in seeing what his demo looks like.
Paul, are you hearing us now?
Yes, I'm hearing you now. Are you hearing me?
We are hearing you.
Great.
Cool.
And
Paul, let's set this up. Are you going to give us an Oak D demo?
yeah,
Cool.
so I was sort of like thinking someone else might do this, but since no one stepped up, I guess I'll just show the basic Linux demo, which that's not the one that I wanted. I wanted the real demo where you can like select the different layers.
This is the Oak. This is the one they used on the Oak D, and it's still in their documentation. I think I know what you're talking about. I guess the Linux. Do you have one that has looks like an application and several different settings and whatnot? Is that the one you're looking for, Paul?
Yeah.
Well, I don't know what it is on Linux because it's just a shortcut in Windows. I have it running if you want me to just bring it up.
Yeah. That would probably be good because I don't know why I had it working, but I don't know why it's not working now.
Okay, so let me try and share and present. All right. Okay. So this is what it looks like in Windows, at least. You have there's a couple of questions that were asked on the list that it's going to address. So in the camera section, you can have color, which is what's on there right now. I can't remember what NN input is, but you can look at the depth. All right, so you can see this is one of the things I noticed. Now, okay, I'm at my hand's at points. I think it's my hand is at 0.6 something. As I bring it close, goes down to about 4. Now you see that where it went all kind of speckly. So that, and look at the number. The number now is like bouncing around up to 1 and whatnot. That seems to be as close as you can get. Is about, let's see if I can back it out. About 4 0.4 meters, which 16 inches.
Well, wasn't it that what they were what they were saying in the specs that
Yeah. I'm just saying,
autofocus?
but I want to say one of the things that's a little disappointing is that, where I'm sure it could be written into the code. You know, right now it sees my hand as one color, but and when I bring it forward, the focus probably messes it up. All right, but it's like the old sharp IR sensors. If you get too close, your number goes weird. So, you know, so if you get this number, are you 6 inches or are you at a meter 0.24? Don't know. Okay. And that's why I say the code could handle this, because you can have regions of interest, and you could say if the standard deviation is too much, or the range is too much, whatever statistic is simplest, you can find out why that's bad reading. Where you can see I'm going to go all the way as far as I can go with my cords, and you can see I have a nice uniform color. So it works past the 16 to 18 inches very nicely. Let's see what else they've got here. You can look at your left camera, which is black and white. You can look at your right camera, and you can look at your rectified left. And what I understand the rectified left is that if this is your camera here, and your let's see how I want to do this. Otherwise, if the camera is fixed so that it's rotated to point straight at whatever the camera is, then that's rectified. Where it would normally be, the camera would normally see it like this. Okay, so you can look at it, read about it. It'd probably be the best thing. Let's see, let's do this. Okay. All right, that's the AI. You can see they're using the MobileNet SSD model, but they do have other options that you can do. And there is a small blurb on how to customize your model if you want. You have some advanced showings. You see right now it's using OpenVINO because it's got what do they call it? Movidius chip in it. And you have the option of which one you want to use. So they're using, I think, the latest version right now. So let's see, anything else? You have.
Doug, does it let you change those on the fly?
Well, you can change it, and then this little bar here comes up and it says apply and restart. I won't do it with the AI, okay? Well, I guess I will. I'll go up here and I'll pick. See, I'll do the open pose too. All right, that's a little different, and I'll start and apply. Now you see how I froze there, and I'm still frozen, so maybe you can't do that. Maybe whoops, here's something. What we got going? Well, I'm not frozen anymore, but I don't see the pose. So I'm not sure exactly I'm not sure what all of these are. I mean, you can see they have some small models. So I'm just going to leave it on the default and apply it and restart. I was messing around with it early, but you know how it is. You try to do something to show people it's not going to work.
Demo effect.
Yeah.
Did you make it full screen, Doug? Does the image scale? Oh, that's
a little bit. Yeah.
A little better.
Yeah. The depth properties, you can change the kernel size. You have a couple options. And you see that, I guess they're using the median so maybe I can play with that when I'm looking at it before. You have confidence thresholds, depth range. It's set to 0 to 10 meters. So that doesn't sound like that should be the right settings, but that's what they're set at. Then the camera. Okay, so this is your main camera here. If you remember, I'm still looking rectified. Oh, let's switch it back. You can change the frame rate. This is the smallest resolution, is 1080p for the
Geez,
color camera.
Take a pause there. Look at that. It's recognizing a chair based on how much? So very little.
Oh yeah, it's pretty good.
Huh.
And the cameras are 720p. Now this was something that some people will be interested in. Okay, I've been running mine continuously, probably as a sense of just to, kind of make sure it doesn't die prematurely. But you can record the frames per second of the cameras. You can record the temperature, the CPU, and the memory. And the temperature run is about 60 degrees centigrade, which is about 140 degrees. Now I took my little flare thermal camera, this little booger, if I can get it in the camera. And I put this on my Amazon tablet, which is the only thing I've got that's Android based. And it showed around 125 degrees from the case. So Paul was talking about heat. So somewhere between 125 and 140 degrees Fahrenheit. So that's continuously running, and that's running the demo. So, it's straight out and it's doing all of this stuff. So it's pretty much.
Doug, I got about 140 degrees for that same thing.
Yeah. So
seemed pretty hot. My hope is that when it's just running depth, which is what I want to use it for, that they won't use that many CPU cycles.
okay.
David, you got that on the case, 140 on the case, and that's in your office where it's not loaded by the sun outside in Texas, right?
Mhm.
Well, that's a good point.
I mean, a lot of us work with these on the outdoor robots, and I'm thinking we get to those 95-degree competition days in the sun, and
I had to add a fan on that little black case on the back of the outdoor robot because of that very thing. It all worked fine until I got out in the 100-degree heat.
Every robot needs a parasol in Texas. That's right, Carl.
Hey, well, we've got telescopes in the air that do that now, right? So why
You
not?
bet.
The other thing I observed was, okay, my Raspberry Pi, I had removed the SD card and was using this little tiny, what does it think it is?
SSD.
No, it's not. What is it calling it? It's a human. No, not a human. What is
TV
it?
monitor. So.
Can't remember. Anyway, I was using this.
SSD.
Yeah, this is an old Oz SSD, and I'm just using it on the Pi since it's a little more reliable than an SD card. And
It said it was a TV monitor.
was that what it was? Okay, TV monitor. And when I did that, so it was hooked up to the USB 3, and when I hooked up the OD Lite to the USB, the combination of the load of both of those USB items was enough to crash the Pi and the OD Lite. Now I didn't do it immediately. I mean, I might run a minute, might run them a few seconds. It was kind of iffy how long it would run, but eventually it would crash. So what I did is I disconnected it, put an SD card back in, and so now the only load on it is the OD light, and I've had it running for days with no problem. Now the other thing I did just to see, since I had one, this is the little splitter that they sold, which has let's see if I can get, I don't know why. God. Why can't I find that camera? What's it doing?
Go down a little.
Oh,
Yeah,
wait a minute. Okay, all right, okay.
Targets your oak.
Wrong camera. Okay, so there was two USB 3s in and one male USB out. And it's got two symbols on it. One is a USB symbol and the other is a lightning bolt. And I used that and plugged an external USB supply into it and the Pi into the other one. And then I had enough power to run with the SSD without any issue. So if you had an application which was not necessarily robotic, but more of a civilian, you were looking at something like a post mailbox or something like that, then you would, have external power probably, and it would be fine. So let's see, was there anything else?
Hey, Doug, do you have a powered hub, like a USB hub?
That would work probably. That would work.
Yeah.
But I didn't try that. But I
Okay.
can imagine that would work too.
Should have worked.
Doug, do you have any quantification of how much current it's actually consuming?
No, I don't. I haven't.
Given
I do actually have this little USB power thingy that I could try that on and see. That's a good question,
that
Dave.
would be real interesting to know. Given that we're all working in environments that are constrained by what kind of battery resources we have, the fact that it's throwing away a lot of that battery as heat is a concern.
Yeah. Well, I'm not. I'm not too worried about the heat. I think it. I've run equipment where you touched it, it would burn you, and this definitely doesn't feel that hot to me. So I'm not too concerned with it. We'll see. Like you said, in the 90-degree weather, but I love the size. I mean, that little size is just fantastic. It's easily. Now the question is, how usable is the depth camera? That's a whole new area for me. I know some other people have worked with depth cameras before, but for me, it's new. So I'm going to be playing with that. This is a nice application, but I think you have to do an additional, the demo that Paul was showing, which is kind of like the classic old, the one that they had in the OD, and it carries on, it works. The OD and the OD light are supposed to be, from an AI point of view, are supposed to be, actually, even in depth, they're supposed to be completely compatible. But, an OD is about this big, and this one is like this big. So it's pretty big, pretty nice savings in size, plus cost. Cost is a lot less. And the power options, the other one couldn't be powered by USB 3 by itself. You had to have an external plug for it. So they cut the power down quite a bit. It might still be too much for us, but it's still a lot less than it was. Let's see.
A lot smaller than a Kinect,
Yeah. Oh yeah.
Kinects are huge.
I think David did raise a good point, though. Generating all that heat, how quickly is that going to drain your battery if you're running off a battery?
Well.
Yeah, you could use one of those little meters.
You kind of
USB
have
meters.
You kind of have to plan on that if you're going to run a Pi. You know what I mean? You got to think the Pi could be loaded up to 2.5 amps or so, and so if you've got your Pi and you've got power to supply at least 2.5 amps to your Pi, then this is less than that. You know.
I was wondering if maybe a separate battery might be in order.
Well, I've got one of these power things, and I'm gonna have to. My initial plug it in because I'm not sure. I really don't know how to play with this thing. Was that I couldn't get it to work, but that's probably user error, not the battery's fault. So.
Hey, Doug,
Mhm.
cover part of your face and see if it's still or if your percentage of person
Okay.
goes down.
Let me see. Let me dust the crumbs off of my paper plate. Okay, here we go, guys.
Yeah, 92, 97.
Pretty robust. I've found that it will detect. It will say it's a person even if there's only just a hand in the image.
Oh. Well, so we may be screwing it up by showing Doug's hand in the image. Huh? Okay, there. Yeah, it went away. Yeah. Well, it's
When he was
saying
moving
half
the
a
plate
person.
over, it recognized his hand plus the plate as a person.
Yeah.
I did this. I got pretty much the same results with a binder too. So otherwise, about
Yeah.
half a face. And so you shouldn't see my hand now. So anyway, that's cool. What does it say the plate is? So you might get it out.
It said it was a person there for a little bit, but
One of the things that I find irritating about their particular demo is that the labels are always off screen most of the time.
Yeah, they hide up at the top, which is
Yeah.
very annoying.
Yeah, so anyway, so and if you go this way, come on.
yep. Yeah, about half your face, it loses it
Mhm.
either way.
Yeah. So what is it doing now?
0.
What about with the hand?
Nope, nothing.
Well, we can't tell it's off the screen there. The label was off the screen.
Okay.
There's no box.
You might draw a smiley face on that plate and see what it says.
Yeah.
A challenge.
I think it will depend on the model you use.
Oh yeah.
My question is, can you upload a new model
Is it working?
like in the CNN model?
No.
Yes. Yes, you can.
Yes, you can.
Yeah.
Oh, that's great.
Yeah.
Yeah, Paul made an interesting observation earlier this week, which is basically this is like an inference engine that happens to have some cameras attached to it.
Yeah. So you can run a custom model, and there, like I said, there is some documentation on it.
Yeah,
but I haven't seen any good examples yet.
If you're finished with your demo, I'm now at a point where I can pick up and
Here I
screen
go.
where you left off, Doug.
Sounds good to me.
Every move is carefully planned.
Choreographed, if nothing else, right?
Every move is carefully choreographed.
We're a team here, me and Doug. We got it going on. So so
Smooth operator.
are you guys seeing my screen here?
Yes.
Documentation.
Yeah, so this is a very instructive diagram. It's an architectural diagram of the system, and if you look through the code examples, there's just, I mean, I'm astonished by how much code has been developed for this thing. There are examples out the wazoo. I look back on the Git repo, and the example repos have been in existence since 2019, but it looks to me like it might be, some of that code might be even older. But the thing that is noteworthy here is the camera is the yellow box and your computer is the green box. And what Doug was just showing, the Depth AI demo, is running on top of the Depth AI Software Development Kit SDK, which is running on top of Depth AI Python, which is running on top of Depth AI Core. But what I want to talk about here is the relationship between the nodes in the camera and the software running on the host. So Luxonis provides this software development kit and a ton of examples that sit above the SDK, which do things like display different frames, depth frames and color frames and disparity frames and neural network recognition frames with different kinds of networks and such. And you can look through the code and they all are kind of boilerplate. What they all do is they define a pipeline and then they load the pipeline into the device and then they start reading from the pipeline. And so what this image in the yellow box is depicting is two nodes that are part of a pipeline and that are spitting out data to X-Link out. And then USB 3 is used for this X-Link. It's sort of used like a bidirectional network, except it's USB, but they use it like a network in terms of you can send down parameter changes to the nodes and get back data from the nodes. So a typical setup script sequence starts by defining a set of nodes. For example, the stereo node launch file in ROS starts out by defining a pipeline comprising a left camera and a right camera and a stereo node, and then it instantiates links between the left and right cameras and the stereo node, and then between the stereo node and X-Link out. And so that's the definition of the pipeline that's to be loaded into the device. And the same is true for neural network apps as well. They define which neural network is to be used, and that's like becomes a node. And then they open the device and download the pipeline into the device. And at that point, you have these nodes like left and right camera and stereo node running in the device, spitting out data. And at that point, they fire up a Q reader on the host. And the Q reader starts sucking images across this X-Link and displaying them. So that's the high-level view of how this software works. Does anyone have any questions before I move on to some demos?
I have a question. And so this Pi demo, the one I'm running right here, actually at the beginning of that demo, there must be a sequence that loads in that pipeline for.
Yes,
for
exactly.
Okay,
Yep.
That's my question.
So,
Paul, you mentioned RAWs at some point. Are you saying that RAWs is actually running on the camera?
No, ROS is not running on the camera. I'm going to do a demo of integration with ROS, which is pretty slick. But I'll get to that in just a tick.
Okay.
so what you're saying is that the node A and node B are the first two stages of a pipeline, and all the rest of the stuff is done on the pod.
So a better explanation is that you can load some set of functions into the camera, be they a left and right camera reader, a color camera reader, a stereo disparity node, a neural network, or those different flavors of neural network that Doug showed. and they all run on the camera, and then an app on the host sucks whatever they produce out of the camera. So the two obviously have to be designed to work together. Did that answer your question? Doesn't sound like it.
You might be muted, Dave.
Yes, it did. Yeah,
Okay.
Dan, thank you.
Okay. So Doug said he wanted to see what the depth AI demo looks like on Linux, and looks just the same as you showed on Windows, Doug. And so you can, so this is loaded a color publisher, and NN input is the input to the neural network, and then it's got the left and right camera readers and a stereo node that together produce the depth image. And so this is showing person, just like Doug showed, and it does a reasonable job of detecting chair over there. And I'm not sure what's on the left. Oh, it's detecting a bit of a chair on the left. Interestingly, it detects monitor. That's
Potted plant.
the laptop shows up as monitor, TV monitor, and this little like faux plant I have shows up as potted plant. So there are 24 classes in the default MobileNet SSD app. But as Doug said, you can download different AIs, different neural networks, and I have tried some of them, a few of them, like the human pose estimation is kind of fun. It shows an outline of a skeleton of a person that it's looking at, and so presumably there's some way to get at the arms and limbs of the. Let's see. Let's just so.
Oh, cool! I hadn't played with that.
So I think that Paul and David are going to have gesture control of their robots in no time soon, huh?
I was actually thinking that's the exact information you'd need if you wanted to attack Paul.
Okay, so that's just by way of addressing Doug's question of what does it look like on Linux? Really, just the same as it looks like on Windows. And
quick question. So you're running this on your laptop, it looks like, right?
Well, I don't think it's really accurate to say I'm running it on my laptop.
Yeah,
It's
I
really-
understand. So there's
Yeah.
there's stuff happening on the laptop. I guess my question is, has anybody tried this on the Pi? You know, you get the same performance when you do this on the Pi because most of the work is really happening on the device, or do you get lower performance because
You
some
get
work
you get
happens on
lower
the host?
performance. Otherwise, if the first demo that Paul did, which opened up two windows, one was the color camera and the other one was the depth image, and that one runs about at 9 frames on a Pi 4. Okay, on the Windows machine, it'll run it at like 28.
Is that because you're displaying in real time the video, which you wouldn't necessarily do on a fully finished sort of autonomous robot? You won't be looking at that video.
Well, actually, you're right. I mean, if you were doing it for a robot, obviously the information you'd be sending over would be a lot less because, you wouldn't be sending images. and it could be a lot faster. For example, if you just wanted to know, is there a person present or not present? That'd be really quick.
Yeah. Do they have a headless demo or a set of demos that are sort of designed for headless operation where you just get a feel for that?
I haven't dug deep enough to see that particular demo, but there are other demos I think there's one that talks about a region of interest and it just reports like the average value of the region of interest, and it's much faster, I think.
Some of the ROS launch files are headless, and but they let you start up RViz in a separate from a separate window. So yes, there are headless demos, and also with respect to robotics, you may be able to get away with really a considerably slower frame rate than you might want for enjoying full motion video that you'd care to look at. So a few frames a second might be sufficient to identify someone's pose and gestures.
Mm-hmm. Yeah,
and especially to look for obstacles in a slow moving robot like Mowbot.
Mm-hmm.
I think if I can follow on to Chris's question, I think maybe it was inspired by the same question I have, which is that part of our hope for this device was that it would offload all of that work to another device, to an external device. And to the extent that if you look at your documentation drawing there, to the extent that actually it requires a huge amount of stuff running on the host computer, it's not really offloading it. So
I don't know if I'd say that, Dave.
I don't think it has very much slow running on the host computer during normal operations. I think there's some overhead when you have to load something new onto the device, right? And that might be more of a memory footprint than a processor hit, is my guess. The amount of telemetry that you pull back from it is up to you. And if you don't need to actually see the frames, or it's how much you still, if you're processing depth data, you're probably processing that on your host processor instead. And so there is going to be some overhead associated with that. But you don't need it at full resolution.
You have the basically the big brother of this device, is that right?
Yes, I do.
And have worked with it for about a year, is that right?
No, I've worked with it. I've had it for a few months, and worked with it almost not at all because I've been using the RealSense cameras, which are
okay.
Intel.
That was my mistake.
Yeah, I think that I'm not sure who was speaking before David, but that's a key point. Is it's what you have to do, the amount of processing that you have to do on the host that matters. And so I want to move on to another demo that they provide, which is stereo Nodelet.launch. And this, so I'm running this on my laptop, and this launches so it loads up the camera with the left and right camera readers and the stereo disparity, the stereo node, which calculates depth. And you remember Doug showed the a colorized depth image where he put his hand close to the camera and you saw it change color from deeper blue to lighter blue as it got closer. Well, what this app is showing is it's taking that depth image, so exactly the same as came out and was just displayed in a depth image that Doug showed, and then converting it to a point cloud and displaying it on RViz. And so this is actually, so it's hard to tell what it is just like this, but let me zoom around and you'll see. So there's me, and so what you're looking at, this is me in the foreground, and behind me is the shadow of me with my wall, with the wall behind me, as a kind of a plane. And you can see down on the lower left of the obvious screen is the video from the left camera. But what gets to be interesting here is you can turn around and you can actually see my head. Now I'm facing the camera here, but since this is a point cloud representing the 3D image that the camera is reconstructing from the to the left and right cameras, you can see my mouth and nose.
That's cool.
And so I think one of the uses I can imagine for this thing is to take the point cloud and lop it off horizontally at a plane above the robot's height and just above ground level, and you should end up with a obstacle map that is all of the obstacles at robot height within the view of the camera. And if you want to look through the back, this is what it's like inside Paul's head. No, just kidding.
Paul, I think we had a question.
Okay.
Yeah, Levon, I think you'd raised your hand earlier.
Oh yeah. So technically, I was referring to the question pointed out about improving the performance of the camera. So my question is, does anyone use this dedicated GPU in their robots, like for example Jetson Nano or anything like that?
No.
Not the Raspberry Pi is more popular, but people who have more money are definitely using the Jetson Nano.
Okay, I see.
I mean, that's obviously, like you said, would be faster.
I see.
A lot faster.
Yeah.
This does have an accelerator in it, though. It has equivalent to an Intel Neural Compute Stick 2 in it. Okay. So it uses the Movidius chip. So that's already in the OD.
Yeah, what Doug said is important, that it's got I believe a 16-core Intel Movidius, which is a video processing, they call it a VPC, a video processing computer chip. And so that's what does the heavy lifting of all the image data and doing the disparity between the left and right cameras.
And also the neural net model.
Yeah, also the neural net inference engine.
Yeah.
I'm showing top here on my laptop, and this is a pretty powerful laptop. So, this is not at all indicative of what a RPi would do. I haven't tried it on my RPi yet, but Nodelet is the app that's reading the depth map and a whole bunch of other images off of the camera, and it's consuming 23% of a CPU. Others is consuming about 50%, and X is consuming about 18%. So I'm thinking.
What's that topmost item there? Isolated web something rather.
I don't know what that is. I see that when I fire up the camera, but I don't know what it is.
Could be part of the browser. It could be Google Meet. Google Meet is a resource hog. So if you show the tree, you might find
it's not related to Google Meet, because I see it when I'm just running the camera by itself without.
Maybe it's something that's managing the USB connection with the webcam or something.
Yeah, it could be, because you see it's dropped down to like, it hasn't dropped down.
Well,
Yeah, I don't know what.
A moment ago, it was at 133%.
Okay. Why? Yeah. still is. So I don't know what that is.
Virus.
Is the app still running? Or did you just minimize it?
I hope not.
Shouldn't that be under 100%? How do you get to 137% on a?
Because it's a 6-core CPU, so you can actually go up to 600%.
Oh, okay, all right.
So that was what I had, and I guess if there's interest,
If you're on HTOP and doing tree view, you might find out what that is part of or who owns that process. It should be interesting to see it if you have
Okay.
HTOP installed. And never
Right.
mind, it's fine.
Okay.
So
anyway, I guess that's what I had was the demo of ROS, and there's a bunch of ROS apps. ROS WS.
I would respond also to Juan's question. The Homebrew Robotics Group out in California has a bunch of guys who are running Jetson on their robots. My impression, they're all ROS guys. My impression is that they're doing that because they're doing basically all of this processing on the robot. That is, they're just starting with a camera.
Okay.
And doing everything else. So they're not, I don't know that any of them are using the Intel Sense or this device.
I see. I also like Chris' suggestion about running it in the headless mode. I think it will improve the performance drastically.
Yeah.
Yeah.
So this is the code for the stereo Nodelet launch that I was just running. It's not very long, but the heart of it is this stereo publisher Nodelet that hooks up to the camera and pulls in the different image streams, the color image stream and the depth stream and the left and right stream, and then they add a Nodelet that is an image that is a convert metric metric, so that converts pixels into it converts the uint16 depth value in the image, which is measured in millimeters, expressed in a uint16 on each pixel, converts it into meters, a float of meters for each pixel. And then the other Nodelet they start is the point cloud, which takes that depth image and converts it to a point cloud and publishes the point cloud. So it's not that complicated.
Paul, you have a typo.
I do.
Yes.
This is. I'm going to blame it on someone else if there's a typo there because.
Okay. Go down to where the Nodelet definition was. That conversion has an S, not a T. Keep going down, right there.
Oh yeah. Right. Yeah. I've run into a couple conversion.
I don't know. Those things just jump off the page at me. I apologize.
Yeah. And so code dot so if we want to look at the source, plus one source to stereo Nodelet. This is where, can you guys see this or is it too small? I can blow it up if it's too small.
It's all right.
Okay, so this is the stereo Nodelet class, and they start off getting some params, and then here's the key where they define the pipeline, and so they pass in some parameters to this class create pipeline, which is a C++ class. You can find the documentation for it in the API, and they're giving some parameters to it, and then they instantiate a pointer to the device and to the DAI, depth AI device, which is the camera itself, and pass in the pipeline. And this is, I believe, the point, this line here is what loads the pipeline that you just defined up here into the camera. So that's all it takes is to load a pipeline into the camera is one line. Then they connect some image queues to named output queues. So they're using this dev, which is the camera, to get a handle, to get an instance of an output queue for the left and right camera, because they publish them both. And then also they get the stereo queue. They define a stereo queue and enable depth as true. So then they get the output queue for depth. So depth is coming out of the camera, and they're incidentally pulling out left and right just for grins. And I don't know why they read calibration, but then this Ross bridge, I've tried to understand it. It seems to be they're deep into there are Python examples, but these are C++ examples, and they're deep into template programming here, and I'm not familiar enough with C++ template class templating to be able to read the source code for this image converter, but the source code is all there.
So Paul, are you planning to do all this with ROS and modify their examples here, those nodes, or you planning to use Python?
Yeah. I figure I'll use because I'm going to run on an RPi, so I think I'll just use their C++ nodes. And then so this left converter takes the left camera image data off of the camera and converts it from the depth AI format to ROS format, ROS image format. So there's different things like the left and like you tend to swap channels. I dug down into some of the OpenCV calls, and they're swapping red and green or red and blue or something like that. Channel order can differ between different cameras, so they're converting it into ROS's format. And I forget what this camera info publishes the camera, and then they publish the image here or publish the video stream. And then this add publisher callback, what that does is it starts a thread that reads off of the left camera stream. So that X-link that we saw here, where they're starting up the reader, they're starting up a thread that reads out of the left camera X-link out port over USB. And then they do the same thing with the right camera. And then here's where they get the depth and publish the depth. So they're publishing left, right, and depth here. And then they create the pipeline. Oh, here's where they're creating the pipeline. Consisting of a node with a mono camera, two nodes with mono cameras, two X-link out nodes, a stereo depth node, and an X-link out for the depth. And then they set the names of them and set some parameters on the cameras, and some parameters to the stereo converter, like confidence for the disparity calculation. And then they link stereo left to mono left and stereo right to mono right. And then they link in depth, and they return the pipeline. So this was the create pipeline function that was called up here where they instantiated the pipeline. So
Those two minor little lines, right, that you mentioned, the trivial little lines. Yeah.
Yeah, but I've looked at several of these examples, and I guess my assessment is that they all have this boilerplate kind of form where you create a pipeline by instantiating some pipeline nodes, creating some pipeline nodes, and setting some parameters for them, and linking one to another. And then you go back up and you define the pipeline, and then you say load into the device, and boom, it's in the device and it's running. And then after that, you can get a cue from the device and start reading the images back into your computer.
So this RAWs code is what you are expected to modify, or are you expected to just use it and it spits out, RAWs topics ready for consumption by other RAWs nodes?
You could go either way. I think for efficiency, I would think you'd want to modify it, because it spits out a whole bunch of topics. I didn't mean to do that. I meant to run this and show you what it spits out. And let's get that fired up. And so it's producing a bunch of data that you really probably don't care about.
No, that's a.
Oops, hold on, wrong node.
Well, you can. There you go. Okay. Oh.
So stereo publisher, the left image. If you're using this for obstacle detection, you wouldn't care about looking at the left image, except maybe for debug purposes.
Mm-hmm.
Same with the right image. And then here's the depth is what you care about. And I think you probably need some info. And they output both stereo depth and stereo image. And I think the image is the disparity image. I'm not 100% sure of that. But what you're really interested for depth obstacle detection is this points topic, because that's what contains the point cloud.
Is that what's getting displayed right now in Arvis? That's the point. So
yeah. And so it's published by the Nodelet manager and subscribed
point
to
cloud.
by
Okay.
others. And if we look at info.
So that's kind of some of the most valuable information in a way.
Yes. So it's running at about
30 hertz. Okay.
30 hertz. So it seems to me that you particularly for a slow robot, and really for most of our robots are slow by comparison with like cars and trucks. It doesn't seem to me you need to run that at 30 hertz for the purpose of obstacle detection. And my recollection from the trucks I worked on is that they would typically run about 5 hertz.
Space Shuttle ran at 10.
What?
Space Shuttle ran at 10 hertz.
Yeah. So that's all I
Pretty
had.
fast.
That's,
Paul, let me clarify if I can. The difference between just the straight depth image and the point cloud generated from that, the depth image basically gives you a per pixel depth, but that's all. Whereas the point cloud gives you the other two axes. Is that correct? So you actually have an X, Y, Z in the point cloud.
We
correct.
have that in the depth frame too.
You have X and Y and a numeric value representing depth in the depth image. But so I think
It's the equivalent. It's still three, it's 3-axis system.
Except that the X and Y in the depth image are represent the position of the pixel on the screen, whereas the X and Y in the point cloud represents that position in 3D space. Is that right?
That's true. Yeah, it's just a scaling function.
so
But that
And why does it look like it's blowing in the wind?
there's noise in the disparity calculation, and so clearly you would need to get rid of some of this noise and do some filtering.
that probably is related to how close the cameras are together. The bigger Oak D has a wider separation, and that problem starts further out.
So this is what I don't know why depth looks like this. I'm not sure what depth really represents. And then the image kind of looks the same. So I don't know. There's a lot I don't know about this stuff.
So are there two different depths calculated? One that's actually just read essentially directly from a depth camera, and the other that is calculated from the parallax of the other two cameras?
No, there's only one depth computation going on, and it's represented in a depth image coming out of the camera, where you have a monochrome image where the intensity represents depth. But what you need to, what makes it difficult to work with, I think, and the value of the point cloud is, if I can find left, imagine you try to process an image, and imagine that instead of seeing pixel values that represent the brightness of an XY spot in the screen, you're seeing depth. Well, now you have to interpret it, because really there's a cone coming out from the center point of the image, and each point in the XY that has a value sort of is a certain distance back in this cone of depth that kind of like is expanding out into the screen, right? And so you have to do more trigonometry, I would think, to figure out, okay, if it's a pixel at X100, Y100, and it's showing a depth value of 2, what does that correspond to in terms of X, Y, and Z? Whereas the point cloud represents it directly as a 3D array of points.
Right. But that noise is really concerning.
Where was the depth tab with the confidence threshold located? I remember when Paul ran the demo, there was like a depth tab along there was like a all depth, and then there was some reporting and all of that. I think it can also be controlled with the threshold value
really?
for the confidence level.
So you think that noise would just drop down below the threshold?
Based on what threshold you will select.
I just saw a confidence if you scroll back up, one of the parameters to the RAWS node was a confidence. I could see that up in the in
Oh.
the output there. So it's probably getting passed in there somewhere. Not on the source code, but it was spitting it. Okay, yeah, exactly that one. So it gets that parameter from the launch file, I suspect.
Right. Right.
I don't know what that means, but yeah, well, it's getting hard coded here potentially.
So it is passed in, I believe. Just confidence default 200. So whatever that means, I don't know.
Double it and see what happens.
Sure, why not? That'd be an interesting experiment.
And what is the camera actually pointing at in what you were showing? I mean, was it pointing at you or what?
Yeah.
At the wall?
Yeah, it's pointing at me. And
But it's just,
so
okay.
if you look at the RViz image, the left monochrome camera is oops. Oh, that did decrease it.
Did it?
So there's what it's pointing at. It's pointing at me with I've got my workbench behind me in the door, and
I know I don't see you in there. I don't know where are you in there?
Put your hand up, Paul, because it was seeing that earlier.
well, no, look down the bottom left of the RViz window.
Yeah, I see. Okay, I see you. I'm saying I'm looking at the point cloud. I don't see a correlation between the point cloud. Okay. All right. I see. So that blip, that's you.
See, Chris, he's reminding me of Keanu Reeves, and this is the Matrix, basically.
Yeah, and you know, it sort of is harder to see when when I'm when you're looking face on. I found it's easier to understand when you're when you're looking side view.
Yeah.
Okay.
And then I don't know what this blob here is. Maybe that's this other chair. Okay.
Oh, I thought it was your halo.
Well, if you look far behind him, then he casts a big shadow.
Yeah, right.
I mean, the way it looks to me, it reminds me of LiDAR point clouds, right? Because those representations are inherently kind of noisy.
Yeah, it is exactly like a LiDAR point cloud. And actually, look, it's kind of interesting. You can see the 3D structure of my workbench here, because here's the workbench, and then you got the light hanging above it.
If you make the dots smaller and so where is the on the left hand side in the tree here, point cloud size 0.01, yeah, make those like half the size or a quarter of that. So add another 0 there in front, or 0.02. Then you get, I don't know if that helps or not, maybe that's too small now, but I think all these dots were just getting blended together a little bit.
Now there's some resolution.
Oh. Yeah, that's more recognizable, isn't it?
I can see hours of playing with this thing and not getting anything done.
That's what usually happens.
Paul
Yeah.
is about to train, huh?
I can see turning Paul into Max Headroom if we try hard enough.
Well, Paul, I have a question about your previous comment. And I would back up and offer the following analogy. Suppose my robot has a single forward-looking sonar. So that's like 1 point, right? It's 1 point of the depth. Now, suppose I made a line of those. So I've got 20 of them arranged around a perimeter. So now that's like I have a line of depth measurements. So now I take that line and I move it vertically. So now I've got a whole array.
Yep.
So what I want is a depth map that looks like that. I don't think any trigonometry is required. I just need to I want to have a depth map that looks like 1080p sonar sensors.
Well, then you can just use the depth image as is, I believe.
So I don't.
There's no difference. It's absolutely the same.
Yeah.
Good. And that requires, and the camera does all that. All I got to do is read back this array of depths. And I know, a priori, I know where the pixels are because I know where the camera is mounted on the robot.
I also, by the way, I don't think you need to worry about that isolated web code process. That's a Firefox thing.
Oh, okay.
That's what I thought.
So, David, I don't think your statement that you don't need to worry about geometry, I don't think that's quite correct, because just to use your analogy, where if you've tilted the your LiDAR up, for example, to 20 degrees, say, then depending on whether you see a hit at 1 meter or at 2 meters, the 1 meter hit is going to be lower than the 2 meter hit. So if you only care about the existence of hits in a vertical plane, then on a vertical line, then sure, you don't care about the geometry. But if you want to do things like cap the hits above the height of your robot so that the robot will feel free to drive underneath chairs, for example, you would need to be able to determine what height that 1 or 2 meter range was at that you saw at a given 20-degree angle. Does that make sense?
But you know that from the depth map. It's 100%. It's exactly the same thing. It's just a slightly different representation. It might be scaled a little bit differently, but once you know what the scale is, right, you still have to take your robot and calibrate its height against the real world. And whether you do that against a depth map or against a 3D point, the point cloud is just a
You're
different
right.
representation. So that you can, it's no different.
You're right. Sorry, I was thinking about that wrong. You're right. Yeah. So David's correct.
So is the difference whether you want to do your logic in a conical space versus a rectangular space?
No,
So
I was out in the weeds on that.
It's a straight up transform. There's no difference. It's
Yeah, I mean, one is
space.
One is calculated from the other, but again, depending on what algorithms you're using, the point cloud, you know, especially the way things get set up in RAWs, it incorporates even things like where the sensor is located on your robot, right? And it gives you world coordinates of, okay, you got to hit at X, Y, and this is the distance. You know, the depth image is a bit more raw in that sense, right? That's where the information comes from, so it's all there. But it's if you somehow need the X, Y, and the distance in world coordinates, that's what the point cloud gives you, right?
Yeah, if it's that, but that's just a calibration function, right? And so it's like you're still doing it to a known set of transforms so the only time that you're really going to need it is not so much in a navigation thing, but if you're like mapping and you want to know the real world location of things.
Right.
And
if you're just trying to avoid obstacles, you probably can work straight off of the depth image.
That was my thought, and really, the amount of information you're needing is greatly reduced. That is what I really want to know is there something there? Yes or no?
Yeah, I mean, the depth image is a bit more intuitive. I mean, I've worked quite a bit with the 2D LiDARs, which are still very intuitive to look at the output that you get from those. But those point clouds, I mean, I don't find those very intuitive to even look at.
Chris, don't you think this would also solve the problem you've addressed about how the returns are curved when the robot is actually in motion?
Well, that'll depend on how the camera is what the exposure time is in the cameras, right? Because it's the analogy I sometimes use with the LiDAR is you have at 5 hertz, you have a 200 millisecond exposure time to get your full scan, and during that time, your robot could be moving. Now, the camera is okay, it's doing 30 frames a second, so the exposure time is going to be at most 33 milliseconds, right? By definition, could be less, right? So certainly you would get, just based on the frame rate, you'd get a lot less of that distortion because you're using a camera. It's actually going to manifest itself as motion blur, right? And I've used that analogy before with the LiDAR. So yeah, you will get a lot less of that with the camera if it's running at 30 frames per second, and if you're consuming maybe, you don't need to consume all of those frames, but if it's operating at frame rate, you wouldn't get much of that effect of robot rotation while you're sensing.
You shouldn't get it at all because I don't know about these, but the RealSense cameras have a global shutter.
Global shutter cameras, yeah. So it's like.
So probably this
instant.
one does too.
What does that mean?
I'm pretty certain it does. Yeah.
What does that mean?
That means that all of the pixels are coming in at the exact same time.
You're right. I forgot about this whole
multiple
concept.
Cameras. Yeah. So even the left and right image pairs. So you don't have to worry about time as a factor in the synchronization of the cameers.
Yeah,
so all of the pixels have the same timestamp on it.
It's like a 2D LiDAR that spins at infinitely high speed and just takes a scan, and takes another scan, right? And which is usually how it's assumed to work in simulation and not in the real world.
Yeah.
So you're right. So you won't get any of those artifacts that you get with a slow or 2D LiDAR.
Yeah. Yeah. Anybody actually know how the global shutters work? I mean, is it like you've got all these individual cells? Are they like frozen and then read out later or something? Because there has to be some time taken to read. You've got a zillion pixels in these images now, so it's not going to happen instantaneously. So,
I don't know the details. It's all magic to me.
Yeah.
Like Ray,
black box.
Didn't you get one of those global shutters for the H7?
Yeah, I did.
And it's a kind of a square piece that fits down over top of the sensor, right? It looked like it was an LCD of some kind.
Over it. There's a lens that fits over it, but just like a lens that would fit over the other cameras.
Yeah, I thought the way it would go is that, like an OpenMV camera, if this is the sensor, then the lens is on top, and I thought you just slid the global shutter on top of the sensor and then put the lens on top of the global shutter.
No, it's its own separate, like, printed circuit board with a different sensor, camera sensor on it that you attach
different
to the
sensor.
base of. What's that?
A different sensor entirely. It's not like an LCD shutter where it just blocks out the light and then.
Yeah.
This is ancient history now, but in the long ago, I went out and did some field work where we shot these stereo high-speed film of these explosions. And what they did was there actually is a cable that ran between the two cameras that synchronized them. And so what that really means is that the trace, that starts at the top of the screen of both of them are in sync. It's not that there's no time there, but rather that it's all in sync. But still, the explosion moves in the course of, even at high speed, in the course of one frame. You have things that move, so they won't be in the same. Yeah.
And so I was reading on the Laxanis Discord app, they were talking about how there are test points, synchronization test points for the cameras. So and talking about how you could maybe tap into them to synchronize multiple of these OAK-D-like cameras, given some additional firmware work, which they didn't clarify what would be required. But I had thought that the way these synchronized camera synchronization worked was the the readout of a camera LCD actually consists of a clearing the image by doing some sort of pre-charge or discharge of all the CCD cells, and then waiting a while the photons collect and cause voltage to discharge on each of the pixels, and then a readout frame. So all you need to do to synchronize the two cameras is to start trigger that start of the sequence for the discharge or clearing of the image, and then it'll all run together. And what you guys are saying is exactly right, that if the image is moving while they're absorbing photons, then yeah, you're going to get motion blur due to that. But at least the cameras are synchronized. They're not like out of step with one another. And apparently that's a significant issue for the stability of disparity calculations.
Yeah, how the actual global shutter works is still a mystery to me. I just know that it works. You can get some incredibly fast frame rates, like out of the OpenMV H7, you can go up to like 250 frames a second in brighter light. So.
Yeah, I just want to clarify. I think I heard about the motion blur being a result of global shutter or not. I think it's more of
exposure time.
Yeah. So the shorter the exposure, less motion blur. And when it comes to the global shutter or the sequential shutter, is the difference is going from top to bottom. Even if the exposure time is short, the time at which you're actually capturing is different. In global shutter, it should be uniform. All of them should be capturing. Again, I haven't looked into the internal workings of it, but my understanding is that it's going to capture that instantaneous picture instead of sliding and looking through one pixel at a time and capturing. So that is,
so even with global shutter, you have a non-zero exposure time. Is that what you're saying? I mean, you have to have,
yeah,
right?
Yeah.
I mean,
that is to collect more photons, right?
Right. So even with global shutter, at 30 frames per second means your exposure time could be up to 33 milliseconds. Could be less, right?
Mm-hmm.
But it could be up to 33 milliseconds, and then real fast movement. You would still get motion blur even with global shutter, correct?
Correct. And with the other regular rolling shutter, you're looking at, it's like you're taking a look at, like, let's say you're looking through a bunch of holes and you're looking at each hole and making a note of what's found in that hole, which is like the pixel value, one at a time, versus a global shutter, you're taking a snapshot of everything at the same time.
Yeah, I saw some examples of uses for global shutters, almost like high-speed photography, because they showed a picture of a fan, and I forget what the other cameras are called, the non-global shutter ones. It would just look like a blur, but the global shutter one, it actually looked like a photograph of the fan when it wasn't moving. So even though it was at very high speed.
Well, that still requires a very short exposure time. So
That's
your
true.
exposure time is entirely related to how many photons you got coming in at a time,
Right?
And how many you need to register something.
Mm-hmm.
And so if you've got a really short exposure with a global shutter, then they're also all going to be same timestamp. So it will be a clearer image. It won't be smeared over time from pixel to pixel.
Yep.
Yeah.
So this link I posted is from Red. They make really high-end cameras, and it's got a pretty decent explanation of these different shutter types.
Uh-huh.
So for whatever that's worth, and they take it back to film, right? Where rotating shutters. I know on my first DSLR, it had a moving curtain, but
yep,
a two-part moving curtain.
Those are called, weren't those called focal plane shutters?
Yes.
Yes.
It's a little slit that moved across.
Yeah, because it was right adjacent to the focal plane of the film. Yeah.
So did you put that in that link in the chat, Carl?
Yeah, in my 915, good explanation from that Google reference. That's like I said, I think Red makes some $40,000 cameras and such. So
those are high-end cinema cameras, yeah.
Really high end, and they've I think consistently had pretty good explanations when I found stuff there before.
Anywho.
Yeah, I just posted a picture, link to a picture in the chat that kind of shows the difference between the motion blur, rolling shutter, and global shutter. Especially look at the Porsche image there, you can see the difference.
Yeah, and I've seen this before. I tried to stabilize a video camera on a gimbal for a drone camera, and that rolling shutter, it's kind of similar, but it kind of smears the image. Some of these things have different artifacts in what they do to the.
Yeah, I see those curved propeller blades a lot.
Yeah. Oh, you mean they're not like just wicked cool looking with the curved on the helicopter?
Well, maybe.
I thought that was general relativity.
Because one end of the blade is moving faster than the speed of light.
Speed of light, yeah.
You know, that's what limits the forward speed of a helicopter.
Yeah. So I actually have a second demo, if anyone's interested. Just because I'm like retired now and I got nothing better to do over Christmas, New Year.
Well, we're all a bunch of slackers and none of us have anything to offer, so go for it.
Okay, hold on. I've just got to unplug my switch monitors again, and hopefully you guys still seeing, hearing me and everything?
We are.
Okay. So I'm going to present again. Okay, so what I'm going to show now is correspondence between simulation and a real robot. So I'm going for 2 gold stars in 2 weeks here. What we want to do is, first of all, what I'm going to do is start up a Gazebo simulation of the mower. So when I demoed it last week, I didn't have simulation running and didn't have autonomous driving running. So now I've got both. And so this is a Gazebo model of Mowbot, and uses the same URDF as the Aviz model, but you will see some of these wheels go around and around here and tick. And so what I'm going to do is start off an app. So this RL500 odometer out and back app just drives it for half a meter forwards and then rotates, supposed to be 180 degrees. And disclaimer in advance, the simulation works much better than the real robot, but let's just fire that off, and there we go. Off it goes. So it's turning in simulation and outputting odometry, which is fed back into Aviz and results in Aviz spinning the robot in the scene. Okay, so that was the Gazebo demo. So now running the same app on the real robot. One moment, please. That's not what I want. Pi 4 is the one I want. So this is now running on the RPi, and well, I'll terminate it and then start it back up again. So running on the RL500 minimal bring up dot launch starts the app, starts the node that talks to the robot, and also the odometry app. So this is using odometry to tell how far it's traveled forwards and how far it's rotated when it's spinning. And then back on my laptop on XPS 15. I'm going to launch RL500 display.launch. So so the robot is running the nodes, the ROS nodes that talk to the robot and talk to the odometry, and they're communicating with the RBIS node on my laptop, which is reading the odometry and displaying what's going on with the real robot. And as a last thing, I'll start up Cheese. And I'm going to, let's see, how can I do this? Hold on, I need to switch cameras. Okay, switched to, okay, now Cheese should be able to let me select
Video.
yeah. Cheese. Okay, and that's the, okay, so now, oh, what happened?
Whoops.
These, okay, there's the robot down there. You guys can see this, right?
Yep.
Mm-hmm.
Mm-hmm.
And let me get my terminal windows up and RBIS, and okay, so now, okay, just to repeat the setup, I started, I want that one. Yeah, I started display.launch on my laptop on the XPS 15, which is running RBIS, and I started RPi, where's RPi? Got too many windows here. Sorry about that.
Amazing how much you got packed into one screen there, Paul.
Well, it would be more amazing if I could keep it organized. Oh, it's that one, but it's not. So it must be that one. But it's not. So maybe it's the fifth one. I am thoroughly confused here. Yeah. Okay, here we go. On RPi 4, I launched minimal bring up dot launch, which is running on the RPi and launches the odometry and the robot comms node. And so now I'm going to run the same odom out and back app, and hopefully you will see the robot move and the others move. I'm not sure what those beeps were, but that's it. That's the demo.
Woohoo! That's pretty cool, man. Same code in the model and the real world.
Yep.
Are you going to go to the metaverse next? Is that what's happening here?
Thank you, David.
Major gold star.
You're muted, David.
Speak softly.
Levon, because we've gone for months sometimes without anybody actually having a robot and turning it on, that if you actually can turn on your robot and make it move, you get a gold star. And Doug took this seriously and actually includes them in the links for tonight. I always wanted one you could stick to your forehead like when we were in kindergarten, you know. So there's only one gold star tonight.
Anyway,
Yeah, that was a great demo.
that was what I was working. Really, what I was doing at Outrider was simulation that would work in Gazebo, and then running the same apps and same code on a real robot, and hopefully the two are somewhat aligned.
Well correlated.
You know, Paul, you're not actually running. Well, maybe you're not actually running real world data into a simulation. The simulation itself is creating the data, correct?
Correct.
And so this mowing robot, I had to skip last week, so I reviewed a little bit of the recording. But this mowing robot, so it does all the odometry for you. I saw something flash by on the screen. It looked like you're connected to it. There was 2 serial ports, one for odometry, one for something else. So it does all the motor control. You just you tell it sort of the speed of each wheel you want to go at.
Yeah, and I do actually collect odometry myself. I've picked off of the Hall effect sensors and run a couple of wires up to an Arduino Uno, and driving the interrupt pins on it, so it does pulse counting off of the encoders.
Okay, so the mower didn't come with its controller. You created the controller, the low-level controller for that mower.
Well, not exactly. It's sort of a mix. The mower came with a circuit board that can drive the mower around, and it uses odometry, you know, as it drives around lawns in its as-bought configuration. And I've tapped into the diagnostic or the built-in test input to send left and right motor speeds to the left and right wheels.
Okay.
But I can't get the odometry out in a timely manner through that serial link. So I'm doing my own pick the voltage right up off of the sensor and chip it out to my own Arduino. So it's kind of
I have the exact same issue on the Nito vacuum robot that I picked out of the trash that I was demoing some time ago. It has a diagnostic interface. You can do a lot of things, just not really very fast, and you can't get some of the data out fast enough. So you tie directly into the encoder, so you can get those ticks out fast enough.
Yeah.
Okay.
Yeah.
Paul, can you pull out the battery pack and as you did last week and show that? Chris might.
Yeah, sure. So let me just fire up. I guess I'll present again and pull up cheese since I'm a cheesy sort of guy. Are you guys seeing this? Seeing me?
And is this some sort of name brand mower or some? I
Yeah.
mean, what is?
It's a friendly mower from the 2000 era. Can you see what I'm pointing the camera at? The mower.
Yep. Yep.
Okay. So there's a serial cable here that comes out. So this is the battery box. This gray thing in the back of the mower. It used to be filled with 2 large sealed lead acid batteries. I've taken them out and replaced them with LiPos and my electronics. And this is a serial cable coming out of my electronics that plugs into the control module here. And Doug, I was thinking about your concern over not having a stop button. There is actually a stop button here, and this red button on the controller. If you press that, it reboots the mower, which takes it out of built-in test mode. So it will stop at that point. And then pulling the electronics box out, I just got to disconnect the odometry. There's one cable that goes down into the guts for the odometers.
So odometry you pick up yourself, but then the motor speed command you send that to the supplied controller.
Yeah.
Okay. And then this is the robot that's where you're gonna use your OCD light.
Yeah. There you go.
So you'll have plenty of power for that heater behind the camera.
There we go. Okay, so the white cable dangling from the bottom is the odometry connector, that your Molex connector. That's where I tap in, and then the electronics is inside the battery box here, which has a fold open lid, and so the RPi is mounted on this fold open lid. That's the RPi is in this black box. This is the Arduino Uno with its wires going off to the odometry pickup sensors, and you probably can't see it, but it's flickering away. This little LED is flickering away. And then the networking for the RPi, I didn't have this working last week either, but networking for the RPi comes through this network cable into a PoE adapter or PoE injector down there, which then supplies power through the blue cable to the Ubiquity Pico station, and that's supposedly got pretty long range and should hook up to a Ubiquity M2 rocket M2 that's in my attic. So hopefully it'll cover the whole of the backyard. There's a coax down under the Pico station that goes to the antenna. This is just a tippy tip of the antenna here. And then this mid plane, so you can see kind of like the mid plane pulls out for service. And behind it is the batteries down in there. and a this thing is a ideal diode. I presented the circuit diagram of the power subsystem last week, but the ideal diode lets me run it off of shore power, which I'm doing at the moment. So I've got this little buck boost converter that is running off of a 19-volt laptop battery and turning that into 28 volts and delivering 0.28 amps to run the electronics, obviously not the robot. There was some.
Why do you need 28 volts?
Well, because it's actually a 24-volt mower. It had two 12-volt batteries, and lipos can run over the range 22 to 28 for a 7S battery. There was some concern. I think David expressed concern that maybe this knob might get bumped and might jog the voltage really badly. It's actually an encoder wheel. This is a neat little buck boost converter. So if I turn the knob, it just turns like 10 like you can see, like a quarter of a turn is maybe 20 millivolts.
Yeah.
So it's kind of a neat way to power it. And the ideal diode prevents backfeeding the shore power into the battery, but allows the battery to provide surge current into the robot when the motors want to run. And then there's a solid state relay and a DC 5 volt, 24 volt to 5 volt DC to DC converter to run the electronics. Anyway, that's my electronics stuff. And then this thing just like pops back in this little clip thingies here.
So come summer or spring, this will be mowing your lawn.
If I'm lucky, if I work hard at it. There we go. And now I can just like pop it right. Oops. With my cord up.
Chris, I think the idea is that next time we have a Robo Columbus, that we'll let Paul go first, and he'll basically mow a path for the rest of us.
yeah. Then you can follow the mown path. Yeah, and then just drop that back in.
Thank you. Well, sorry if you had to repeat what you already presented last time, but that's great.
No, it's fun. Anyway,
And you're making progress since last time, anyhow. So.
Yeah, I'm quite pleased about the progress since last time. So I want to share that.
Since the year 2000, the compartment that carried the batteries in the year 2000 now has the batteries and all the electronics.
Yes.
And some relatively, well, it might seem small in a way, but in a way they're bulky, like routers, right? Commercial, not at all for this purpose kind of routers. So
yeah,
they're full packaging. They're not. You didn't even have to rip them out of the plastics to make them fit.
Yeah, I got lots of space inside this big old battery box, and the mower is not a small robot, so it's.
So what else are you going to cram in there?
Still a bit to go in. One of you guys was talking about getting an RTOS running on an Arduino, and so that's my plan for the low-level interface. I don't want to have like a Arduino Uno for odometry and some other thing for cameras and some other thing for whatever else. I should have received my ESP32 today, hopefully from SparkFun, and an RTK GPS board. And so thanks to I spaced thanks to Ponder some more. I'm sorry, I've spaced you. Kareem. I now know how to pull down corrections from the web, and so I think between the RTK board with web corrections coming in over that Pico station from my home network, and other stuff running on an RPi, running on a Arduino under an RTOS. Hopefully I can like get it all together to like actually drive the thing sensibly.
We probably, or someone probably recommended FreeRTOS already previously, so just repeating that. But
Yes,
you won't be able to get it working on an Uno. I mean, with one task, yes, but won't be useful. So you'll need something bigger than an Uno with more RAM if you want to use FreeRTOS.
Right. So that's where I'm planning to use the ESP32 running Arduino and FreeRTOS. And I didn't know you could do that. I mean, it was through the DPRG that I learned that. So, you guys, thanks to you guys for educating me on what's possible.
So what? We were actually helpful, or some of this group is
100% helpful.
Holy moly!
Well, I have just an image to show based on our earlier discussion, and not even an image. Let me grab my robot.
So Paul, thanks again. That's pretty awesome. All the ground you covered. That's really something.
Thanks.
So you might just pin the picture. This is the Jbot outdoor robot, and I don't know if you can see clearly here with that little black box on the back, which has the user interface and also has 3 buck boost converters in it. And I found that black color out in the 100-degree heat we were discussing earlier, that it would overheat those converters. And so I put, can you see it? Yes.
Yeah.
There's a little fan on the back, which just it doesn't draw much at all, and it really doesn't turn very fast, but it just keeps the air moving through that little box, and that was sufficient. So anyway, just a reminder, if you're going to run an outdoor robot in Texas, you need to think about heat.
Nice.
And it didn't take much to cool it. That's cool. I mean, neat.
No, I think the problem was just that because it's kind of sealed up in there, it's like a little oven. It would get out there and it would get so hot I didn't want to rest my hand on it.
I'm not really kidding about the whole parasol thing. I'm trying to find a very dainty ladies parasol from the 1800s.
You gotta have some frill and stuff all the way around it and everything, right?
Well, I'll say I've been running this Oxy Light through this whole session this evening, and it's hot enough that I really don't want to leave my hand on it. It's not going to burn me, but it's hot.
And that's the same demo code as we were seeing earlier?
Yeah.
Yeah.
With image recognition on it.
Yes, it says I'm a person with 95% confidence, which just makes me feel great.
So David, so you obviously have to then use also a Raspberry Pi, right? I mean, you kind of have, this is not designed to be used with an STM32, is my understanding.
Yes, the answer is yes. That's actually a BeagleBone.
Yeah, I was just going to say, it looks familiar. It looks like one of those old BeagleBones. I mean, they're old banner.
Yeah, you remember I was talking a few months ago about adding a Raspberry Pi as a peripheral, and basically in this case as a visual processor.
So your main logic, you still plan on using your STM32 for the main logic, and you just You know,
Yes, the tail will wag the dog.
Yeah, there's more compute in that camera.
Yeah, it does.
Well, this, Paul, do we have time here, Carl, or I just wanted to kibitz a little bit.
I think we do. If you got some more,
Well, I had just
else wants to jump in, just get your name in the list and we'll talk. Go ahead.
Well, Paul gave us a nice talk on behavior trees a couple of months ago. And then Rudd, who's not here this evening, expanded on that some. And we had a bunch of questions, Paul, and that's just as you left town. Like any good politician, you made your speech and left town. So I'm now going to, what I'd like to do is recite a scenario and then ask some questions. Rudd's implementation was much like yours. And what we were looking at the time is the idea that subsumption architecture could be modeled with behavior trees. The behavior trees were a more general case of which subsumption could be a more specialized case. And you had shown us your implementation and Rudd showed us his. And the question I had along the way, and let me back up a little bit, in a what I'm going to call a traditional subsumption engine, you have a bunch of separate and disparate tasks, behaviors that read sensors and look at state, and maybe it's virtual sensors, maybe it's real sensors, maybe it's more than one sensor, and they look at state and they generate their outputs. And the subsumption engine runs all of those in sequence so that they're synchronized. And then at the end of that, it goes back and it picks the one that has the highest priority and passes its outputs along to the motor control subsystem. Now, in the example that you showed using behavior trees, which I'm intrigued by, and the one that Rudd showed, basically, it seems that it implemented the logic structure of subsumption, but not the structure of the subsumption engine. So I asked Rudd that question specifically. I said, all right, now you're going down the tree, you're going branch to branch, and you finally hit on a high priority task and you execute it. So none of the tasks below that actually get executed. Whereas since they're keeping track of state, every task needs to get executed every time through the loop. They may be running their own filter. So even if their output is not used, they need to be run. So I asked Rudd, how do you deal with that? And he kind of made vague references to a big block of globals that were all maintained sort of behind the scenes by what would strike me as the rest of the subsumption machine. So it seemed to me that both his description and yours, the logic of subsumption was there, but the subsumption engine itself was not, nor was it constrained or defined by the behavior tree. So I don't really see how, well, you see my question.
Yeah.
Do you want a while to ponder it?
So just to clarify, you presented a design, not an implementation. But I think you're correct that the behavior tree that I presented the design of would not run all of those blocks every tick. Does your subsumption engine actually run all of the behavior? Because I thought it stepped down the modules and whichever one said, I want control, that got it, and it didn't go down the rest of them. That's an incorrect assumption? You're muted, David.
How about now?
Yeah.
It actually runs, the main loop runs each function in turn. And then at the very bottom of the loop, and so as I say, so they're all synchronized. And at the very bottom of the loop, then the arbiter looks through the outputs of those that have just run, picks the one with the highest priority, and passes its outputs along to the robot subsystems. So as I say, suppose you have a task, it's a low priority task. It doesn't win this round, but it's running a low pass filter. And so it needs every time around it needs to run and do its operations, even when it doesn't give you an output. The way that Rudd described it, as I said, he described what the logic of subsumption, but not the actual subsumption engine. And when I asked him about that specifically, he said, well, that sort of stuff's kind of running in the background and filling this big global block, which is all fine and good. But as I say, that if that's the case, then the behavior tree definition doesn't do anything to help you with the rest of the subsumption engine. You've only gotten half of it. You've only gotten the logic half of it.
And the
Isn't
rest,
that the important part? In other words, haven't you made a choice about um, the way you construct it, that you're doing updates to sensors or sensor interpretation um, as within your subsumption, your separate states or whatever you call them. You could be doing a global sensor interpretation processing loop that then feeds into your sort of decision tree.
I think there's a couple of problems with that. The first is that, as I mentioned before, you need to be able to keep everybody synchronized, and not just with each other, but with the logic that is reading their outputs. So if that's not defined within, which it is within a normal subsumption engine, that's defined for you. So if that's not defined by the behavior trees, then it needs to be defined some other way. And then the second problem is that by keeping all of those things local, it allows you, at least in theory, to make changes to any one of those behaviors without affecting other behaviors. So that's part of the design of the subsumption architecture. And if you're going to break up that design into a separate logic part and execution part, I'm not saying it can't be done. I'm just saying that the simplicity of doing it with the behavior trees seems to kind of go away if all that has to be done separately.
it sounds like you've got a two-stage process in your subsumption tree. You've got an execute the tree modules, and then a take action based on the output of the tree modules. So it goes 1, 2, 1, 2, 1, 2 all the time. I don't see why you couldn't take all of those, do that equivalently, execute all of the modules in a pass, just like you do in the subsumption engine, and record their outputs, and then run the behavior tree on the output of each of them.
Yeah, I think that is what you'd have to do. But in that case, the simplifying model of using a behavior tree doesn't really cover the whole thing anymore. So the reason to do it that way seems less convincing to me.
It was to me, it was a intellectual exercise, because you and Rudd seemed to have agreed that behavior trees could model a subsumption engine, and I wanted to find out if that was true. And so I learned enough about behavior trees to convince myself that it was true.
I'm less convinced now, but maybe it's just because I don't understand it well. I wish Rudd was here next time he's here, because he was pretty convinced. He started off by saying, subsumption is basically just a formalization of a bunch of OR statements, which is true. And I know there are probably other members in this group who go back to, to the 80s or the 90s with their robot building. And at that time, before I had learned about subsumption, we were writing our robot code as, these great big long strings of if then else statements. And real quickly, that just gets out of hand. I see Karim grinning. It can get unmanageable, And so subsumption came along. It was a way to formalize those things and reduce them in a very simple way that was controllable and predictable. It looks like that in the meantime, the guys who were writing computer games just kept writing bigger and bigger and bigger if then else statements until they came along with behavior trees, which was a way to try to regularize and simplify that. And it does seem like that it covers a larger, more powerful set, of which the subsumption is just one, is just a subset. But as I've looked through it and I thought about, okay, how would I actually implement this? It struck me that a whole lot of the subsumption engine would still need to be there. That all you've really done is abstracted out the decision-making part and not the rest of what makes the engine run. And as I say, my opinion about that has changed and it may change again. So I'm really just thinking out loud here.
I think that all that other processing stuff is universal. Every system has to do it, whether it's interpreting sensors or creating virtual sensors or whatever. That's got to be done regardless of how you execute decisions about what the robot's going to do. We just use state machines for all of our decisions, and I think that they're all basically equivalent. Whatever method you use.
You pointed out last year that subsumption is another way of formalizing the organization of state machines.
Yeah.
That resonates with me. That makes sense.
Yeah, I believe that's true also. I thought about that, but it's just a horrible looking state machine if you try and draw it as a state machine, because you've got all these, every higher level node state can go down to any number of lower level states depending on the transitions, and it just gets really horrible to think of it that way. And subsumption is a really elegant way of expressing that, but it could be in principle, I think, expressed as a state machine. And all of your points are well taken, David, about behavior trees. There's some trade-offs, it seems to me, here in terms of flexibility to add different behaviors, like a different behavior when you're approaching a cone versus when you're navigating around the course, that maybe could be helped by switching into a different branch of a behavior tree. But I'm not going to say that either approach is not feasible.
Well, that's all I had. It's just something I've been pondering.
Good question.
I might ponder it some more if that hadn't already been taken.
Well,
Kareem, I'm assuming there are no updates regarding the Pioneer. I know they're not going to ship for another 10 days, but I hope the shipping costs haven't gone up since your last email.
I haven't heard anything about it. I haven't even reached out because they're not even going to pick up the phone until the 10th. I'll let you know as soon as I find something out.
In the meantime, we can all go dig the mud out of our basements.
I feel for him. I don't even know how you run into that situation, but
Carl, you're muted.
Yeah, it's been dogging him for 6 months, so hopefully he'll get past it.
I shouldn't really speak out of turn. We've had our basement flooded because we're like sitting down on a we're sitting below the crest of a hill, and so water comes in those really big rains that we had a while back. Water would come flooding down and our driveway and goes right into the garage. And if our French drain isn't maintained, or
I think that's the same situation Murray's in. He's on the side of a hill.
Yeah, that makes sense.
Except his hill is in New Zealand.
Yeah, he's got a better location.
And he's got a better view.
He's definitely got a better view.
All righty. Well, looking around the table, anyone else? Pat, I keep looking longingly at this big robot in the background there.
Got a big red button on it.
Yeah.
It's it was having trouble, couldn't get the wheels to spin, and I was trying to figure out what was going on and what was happening. And it was a change I made, trying to wait till the complete serial message was in. But I had my the message length was wrong, so the message was never equal to 12. The message length. So I've got that fixed. So hopefully next week I'll have a robot to demo. I'm close.
Nice.
So I was working on infrared time of flight infrared today. Arduino's working on my arbitration routine right now, trying to get everything pulled together. Hopefully I'll have something next week.
Very cool.
And is that a big giant power switch?
That's the main battery switch, yeah.
Yeah, looks like a battery cutoff.
Yeah, it was $10 on eBay or whatever, or on Amazon, and okay, I'll buy one. Makes it easy to turn off. And so far, I got Carl's idea to hook up my battery charger and keep it running.
Kill switch.
Yep.
At some point, we need to wire up one of those big buttons to where it ejects something from the robot, right?
Just short out some LiPo batteries; they'll eject.
That'll do it. Dave, is that a wave?
Out of curiosity, Paul had mentioned he's using Ethernet on his robot. So I was just, while we were talking, I did a search. Can you put Ethernet on an Arduino board? And definitely, you can buy a shield anywhere. If you buy an SPI shield for about $15 Canadian, and just plugs into your SPI port, and there's all sorts of libraries. So I was looking at it. I could eliminate my serial connection and go direct to Ethernet MQTT.
But Paul is using Wi-Fi, right? It's just from the Pi to that Wi-Fi gadget. It's an Ethernet link, right?
Can't hear you, Paul.
Paul, your mic's off.
It's just some fancy Wi-Fi gadget that you connect it through Ethernet. It looks like.
I'm struggling with this and welcome anyone who has input on this, because one of the things that we always ran into at the DPRG contests is everyone's on Wi-Fi and everyone's Wi-Fi interferes with everyone else's Wi-Fi, and it's just a mess trying to get the things to work. And so, yeah, I'd like to have the ESP32 running Arduino use Ethernet. That way, I don't have a problem with an Ethernet transmitter on one channel being adjacent to the main Ubiquiti uplink back to my house or wherever that's going. But I'm concerned that the APIs may be different, because it seems to me that the Arduino API for the Ethernet presents it more as a kind of a serial link, if I understood it correctly.
Yeah, those Arduino Ethernet shields that they use this. They don't use a raw Ethernet adapter, if you may, like in the old PC days. You had your Ethernet adapter, you put it into your whatever slot, right? And it's just a pretty dumb device. But yeah, those, and you get the same kind on the Wi-Fi world too. These are chipsets or chips that implement some smarts, and so they implement even the full network stack, right? And so they give you a much more abstract, but in some regard more primitive interface, into the networking world. And I've seen those kind of chips before, and that, yeah, it's a different API therefore, because you don't get a raw network adapter on top of which you have some device driver. You get a much more of a turnkey thing that already does a lot of work, but it's going to present itself very differently.
Yeah, and so I'm sort of wondering what the ESP32 Wi-Fi API is like compared to the API presented by one of those shields, one of those Ethernet shields. I haven't looked into that, but when I looked at the Ethernet shields, they had a pretty simple API. And if you're dealing with an RTOS, you'd really like to be able to arbitrarily open sockets, for example, UDP sockets between the host and the Arduino tasks. And it seemed to me that was probably possible over Wi-Fi. I don't know, but they run a full network stack in that ESP32 versus the shields, the Ethernet shields, really just have a serial port, and they spit out some set of bytes that represents a packet that came in and a packet that's going out, and it doesn't really present as a socket, if it will. So that's kind of what I'm struggling with.
But on your robot, I mean, where does Ethernet fit in exactly? Can you say that again, because that wasn't clear to me? I mean, is it for communication on the robot?
Yes.
Why not? So the obvious alternatives are too slow, like USB and UART or a SPI. Right? Would it be for communication between let's say an ESP32 and your Raspberry Pi? Is that what you're thinking?
Yeah. And yeah, that and the camera is obviously, well, camera is obviously going to be USB.
Yeah, I understand you said, you made a point about, yeah, you don't want to use, let's say, the Wi-Fi that's built into the ESP because you don't want to cause sort of interference with the uplink. I mean, that makes a lot of sense, but I'm not sure why that then necessitates Ethernet from the ESP to the Pi. I mean, there's USB.
So I'd have to come up with my own kind of link in some fashion. And one thing I've thought about, and I'm just like throwing out idea or looking for input here. But one possibility would be to use ROS serial, and ROS serial can run its node down on the Arduino and effectively have multiple streams across topics going up to.
Yeah, in your case, where if you don't want to invent some other protocol, I think that's absolutely right. You could use that, and you just need the physical connection, and yeah, you could put that on top of.
I'm using Python with serial to do that with my Arduinos.
You what?
I'm using Python and with serial. So my interface into my robot is through a Python routine to the through the Arduinos, one for the motor drivers, one for the ultrasonics and time of flight sensors. And so I have two routines running, and they're both communicating across USB serial right now. It seems to work okay. I did have a problem with some latency on the communication, and I think I'm coming down to the end of it. Is that if I try to send something before I open the port, I fill up the MQTT buffer that I'm using, and I end up with 30 or 40 seconds of data coming in. So my wheels are 30 seconds late in responding to a command. So I think I've got that sorted out, where I wait until my serial connection is up before I start producing any data.
Paul, how much data do you need to move between your ESP and the Raspberry Pi?
I have not calculated that.
But do you think like 100 kilobit or a couple hundred kilobit UART link would be sufficient?
I hope, because it's really just commands to drive the wheels and robot feedback of voltage and.
Then it would be sufficient for sure.
Yeah.
Well, again, there's USB, right? If you don't want to, again, there's a shortage of just raw UARTs on the Pi, but I'm not terribly familiar with the ESP32s and what kind of USB they give you, but like Pat just said, chances are you can just connect it as a device to your Pi, and it looks up as a serial port anyway. It happens to go over USB physically, but on the Pi it looks like a serial port.
And certainly you can do that, and it really all amounts to having a process down on the Arduino that muxes all the messages, muxes and demuxes the messages bidirectionally. And again, also up on the host that muxes and demuxes and filters them all down through the single channel, sequencing them in turn. And the reason I would rather not address that problem is really exactly what Pat just described. You know, he's running into all of the problems that you always run into when you try and get two things to run multiple logical channels that are asynchronous across a single bidirectional serial port.
Amen.
But I mean, you know, again, so I do something very similar. I mean, I think Pat is running into the problem because he's using MQTT, which you can debate whether that's necessary here. But in a case where you have something like a Pi and something that's a little more dumb and a little bit more level, right? The two need to exchange information. There isn't really necessary, you know, just don't make it so that multiple things on the Pi try to talk over the serial port. Just have a single piece of code on the Pi that manages the connection to your ESP32. It pulls the data out that it needs. And then now on the Pi, the data goes where it needs to go through whatever mechanisms, whether that's RAWs or something else, right? So in my case, I could have used RAW serial when I do, you know, my work in RAWs land, but I just do something very simple, get the data out into Python script on the Pi. It then publishes, it becomes the RAWs node, right? It publishes the data over, you know, in the RAWs format, or I consume the data just more directly through other Python scripts if I don't use RAWs. And so there isn't really any synchronization necessary. There's really just one entity on the Pi that's talking to the, you know, the microcontroller that's more a data gatherer. And yeah, you can run into issues with a little bit with latency and you got to make sure you do the parsing correctly of, you know, as the data just comes in, you got to make sure you have a way of knowing, okay, when does the packet start and when does it end, right? You got to have a way for doing that. But beyond that, it's you can keep it fairly simple, or you could use raw serial.
I had really good luck with raw serial for communication, and my latency was way down. It's just the learning curve to do the rest of ROS was just enormous. I found it wasn't very difficult to implement on an Arduino with ROS and the Raspberry Pi to communicate across ROS. But it's the rest of everything else you want to do. You want to start using RViz. You want to use path planning. You want to use AI, whatever. It's just a huge, huge uphill learning curve.
To address what you said, Chris, yes, it's all doable. Conceptually, though, or if you think about it architecturally, you really do have multiple independent things operating at different rates down at the lower layer. So you've got odometry coming in at whatever you decide its rate should be. You've got bumper sensors coming in at probably a slower rate. You've got motor commands going out at some different rate. And
yes,
whatever else,
I see what you mean. I see what you mean. So you're totally right. What I do to simplify that, I just publish, quote unquote publish, meaning just dump the data out from my Arduino node at a fixed rate, at the highest rate at which I want to operate.
Yeah.
So at 100 hertz, let's say. Yeah. My sonars are not coming in at 100 hertz, of course not, right? So I'm obviously, I'm just constantly at a fixed rate, publishing a fixed amount of data. Keeps things as simple as it can be, right? Now you have a fixed packet size, if you may, right? You don't have to worry about different types of packets and different sizes. You just pump the same data out every time. And yes, it's more redundant, right, than necessary. It's less efficient than possible, but it's simple.
Architecturally, it's pervasive, though, because it feeds into the architecture of the lower level thing, which conceptually should have tasks that have discrete areas of responsibility and run at a rate that is appropriate to whatever they're doing. And you end up having to like munge that all together and run it maybe at, effectively it all needs to.
You can still run everything at the rate that it wants to run. I guess what I'm saying really just applies to when it's time to now get all this information from point 1 to point 2. You just pretend it all runs at a high rate, right? And so for 10 iterations, I might be publishing the same piece of sonar data just because I haven't gotten a new one in yet.
So when you do that, Chris, do you have some kind of fresh bit so that the receiving end knows that it's seen this before or this is new data?
Not currently. I know what you mean. I've thought about it. I haven't found it to be helpful or necessary.
I would have to agree with that. Even though I work in a different environment, I do the same thing. So if the update rate for the packets are 100 hertz and the sonar only comes in 3 times per second, then 30 of those packets will all return the same value, the most recent value. And what I found in practice, and I think maybe this is what Chris was suggesting, is that it really doesn't make any difference. The main controlling processor doesn't need to know which of these are brand new. It will change when it's new.
Exactly. I mean, the main controlling process, right? It as you consume the information, you kind of baked into that logic tends to be a notion of, well, how, what's the responsiveness of that sensor, right? You're not going to try to do a very fast response kind of wall following with a sonar that gives you, data only 2 times a second. So you have that somehow baked into your logic, but the fact that you have a lot of data coming in that's kind of repeating itself and then suddenly changes and repeating itself, 5 times, 10 times. Yeah, it doesn't, I haven't run into a situation where I wanted to know exactly when did that new data come in.
I was just thinking from the perspective that if you're, for example, CPU cycle constrained, and if you have to be judicious about when to compute things or not, in that kind of world, it could be helpful to say, this data is old. There's no need to run the computations on old data because the output's not going to change. So if you have a lot of data that's relatively stale every time, then that's one area where I could see it could be useful.
Well, that's a good point. I will say that, like, for example, in the sonar readings, which are not changing very often, but when I receive them, I calculate their actual XY location. And I do that every time, whereas that really only needed to be done once. However, if you only did it once, then the code would have to know to use this old value rather than recalculating a new one.
More complicated that way.
Yeah.
Right. Trade-offs, standard engineering trade-offs, right?
Well, thanks for the info, guys.
Well, cool. All right. Well, we've lost a handful of people. We still have a dozen online, though. Anyone else? Or shall we call this going once? Going twice? I'm seeing some hand waving, so it sounds like a good time to get some rest. Guys, great chatting with you. No meeting this Saturday, but we'll meet next Tuesday and then the following Saturday. So until next Tuesday, have a good time.
Take care.
Good night.
Good night.